There's no grade, it's okay.
That was funny, actually.
I couldn't believe she said it.
It's like, it's the gradual progression over 10 years, right? That she's sort of like, wait a minute, you're gray.
Think of how much she'd had to drink.
Oh, yeah, that's a good point. Right.
I mean, she gets loud and obnoxious. She actually yells at Paula to not.
It's a good thing we're not mentioning names on this recording right now.
Yes. Friend of family.
Oh.
She's had a few drinks. She starts defending our daughter. Yeah.
All right.
It's funny. It's hilarious.
It is. It's pretty good.
She's the one that looked at him and went, "Wow, you've gotten gray." Yeah, almost lost it.
Oh, so on that note,
welcome.
welcome to the May Omaha Linux Users Group. Speaking of gray,
It wasn't May already.
I did some sleuthing on the mailing list, and I found that the first meeting announcement I did for the list was in December of 2004.
Jeez, I was.
That's after Tim left.
I was still in high school.
That was.
Yeah.
Hey, can you do me a favor?
Yeah.
Pull up the OLUG page.
Sure.
What's broken on it?
Okay. I guess we'll find out. It's caused me a lot of grief.
We're gonna find out.
Has it?
Yes.
Well, if we had somebody who had time.
Just wait.
Does it still say error database connection?
No.
No, it's something about the meeting tonight.
Oh, well, maybe it does.
Is this the at work Apache?
So, when it loads, scroll down to the meeting announcement.
May.
What did I do wrong?
What is wrong with that picture?
Presentation. Adam Haeder, presenter. Mininet.
Oh.
For the last 3 months.
Has it?
So
Well,
I've been told.
now you know my secret that I'm just copying and pasting and changing.
I did too.
He did it on purpose. He did it on purpose. See if anyone was paying attention.
Thank you.
Clearly.
Hooray!
Way to catch it.
I'll try to change that before the night's over.
Something's.
Go back in time.
All right. Everybody knew what he meant.
Did you tell me this before and I forgot?
No.
All right.
I just found out about it yesterday.
Wait, is Mininet presenting?
Adam Haeder.
That's exactly right. That's
I just.
This is my presentation. I have an Adam.
Mininet has an Adam.
Right.
Full hour with it.
How far did I get? Oh, yes. I'm John Larson, system engineer at AIM. Tonight,
Hi, John.
Been doing this for
Hi.
12 years, huh?
for 12 years. That's right. And I'm not even the president.
You haven't caught up to Anime Sunday numbers yet.
No, we haven't. That's now 21 years for Anime Sunday as of last month.
John runs Anime Sunday.
Yeah.
21 years.
And I'm running out of shows.
You watch them all.
We actually had...
Wait till Attack on Titan Live comes out.
Oh, there you go. We had a show that was 110 episodes.
Jeez. You
And
watch them all?
we watched up to like 26. Then we took a break for like 3 years. Then we started watching them again. So we finally finished it. For now, we're watching another show that has 108 episodes, and we're at like 96.
Oh, boy.
What shows that?
Cheese Sweet Home. It's like a 3-minute. You know how the old movies, they would show little cartoons before the regular show? That's how we positioned it. So it's like a 3-minute right before the regular show, before it gets serious. There's 2 series of that, and I haven't gotten the second one. Anywho,
a lot of anime shows that were only like 20 or 30 episodes.
well, a season is typically 11 to 13 episodes. So if it's 26 episodes, that's 2 seasons, that's half a year. 52 is 1 year. Typically, they take a break around Christmas time, so that's why you only usually have 49 or 50. So, all right. I'm interested to hear what Mininet is.
All right.
I'm a little in the dark on it, but I think I read your description, so it should be good.
All right.
It's a net that shoots out lots of pages really fast.
There you go. Done.
Maybe this will be faster then.
There we go.
TLDR.
Thank you, John. You're welcome. Mininet. I failed to make slides tonight, sorry. So I'm ready.
So you made browser windows?
Mininet, yeah, I've locked tabs open. Mininet is an example of a simple Linux-based implementation of software-defined networking. What's software-defined networking, Craig?
software defined. So instead.
Craig, I said, not Greg.
Your name is Greg.
Craig.
He started.
Software networking.
Well, they do sound similar.
Being able to control one location.
Be able to control things from one location. All right, that's good. Greg, give me your definition.
Rather than have the routers do it hardware based, you have something dedicated to do it to do all the routing calculation software based, and then push it out to the router.
Right. So it's control and command and control of a network based on software. Right. So in the bad old days, back when I did this, you had to manually configure a lot of routers and a lot of switches. It was a giant pain in the butt.
You mean battle base.
Or some.
Now he gets somebody else to do it.
Today, you still have to do that. Right? So software-defined networking was created in order to alleviate this, right? So I kind of think I always think of it as what to networking as virtualization was to software deployments, right? So we're separate with virtualization on the operating system side. We separated the software from the actual hardware, right? You put a layer between, which adds overhead and complexity, blah, right? But what it gives you is better because you get more control, you get more flexibility, and you get to move things and change things independent of the hardware underneath, right? So that's the same idea with software-defined networking. You've got a network set up, hardware-wise, right? Router, switches, cables. You don't change that. But if you want to change your network topology, you change it in software. The first versions of this, you can make the argument that VLANs were the initial implementation of software-defined networking, right? Because what do VLANs allow you to do? They allowed you to move systems between subnets without going out and doing the old 1940s operator thing, right? Boom, 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 this, like we used to do. Yeah. You do it on software, right? This is kind of the logical extension to that. That's what it looked like, right? They did this right here. Right
I watched Mad Men.
Hello, hello. Coming through. Yeah, do that.
Watch the video. Dial Comes to Town on YouTube. You will see it.
So that's the idea. So software-defined networking, the major implementation of it is an open source stack called OpenFlow. It has been around, if you search for information about this, about late 2011, 2012 is really the earliest mentions you're going to find of OpenFlow anywhere. So it's pretty new, even for our industry, which is young in this grand scheme of things, right? This is pretty new, right? But it's been embraced by the major vendors as a way to handle the configuration of their devices. Even the big vendors like your Cisco and your Junipers or whatever will be OpenFlow compatible, which means that you can configure it the old crusty way, right? You can tell it into the router and console in the router and do your own fix, or you can actually make your configurations with an OpenFlow compatible piece of software and then push the config to it. Okay? So, software-defined networks are a thing. That's the point, right? What we're going to look at today is an application called Mininet, which is simply a SDN testing environment that's very, very, very easy to implement in Linux, because it takes advantage of the fact that the Linux kernel has a lot of this virtualization and sort of link and networking separation built into it. You don't have to do anything weird. It's very easy to do. So like a lot of things in Linux, you don't actually need the Mininet software to accomplish what we're trying to accomplish. Mininet just makes it easier, right? So you guys remember the Linux terminal server project? Way, way, way back in the day, right? Yep. That's another example. That kind of stuff, you could always do that in Unix. It was taking advantage of a fundamental piece of X11, right? LTSP just made it really easy. Okay, that's what Mininet does. It just makes it really easy, right? So you can kind of read the description here. Oh, let's walk through the setup here. So what I have on here is I have a VirtualBox instance of a Mininet VM running, just to make this setup really easy. And the documentation is actually surprisingly relatively good. And so we're going to do a couple things first. First, I'm going to go to my SSH session right here. Okay. So this is actually SSH into the VirtualBox instance that I have running on my laptop here. And I'm going to do this first. What's Wireshark? It's packet sniffer, right? So I'm running Wireshark in my terminal window. Oh, look at that. It came up on my Windows box. How'd that work? X Windows, right. So, yeah, it's just telling me I shouldn't run it as root. I'm telling you, I don't care. Yes. Don't show this message anymore. Right in the low. I have an open source free X server running down here. You can see it right there. It's a Windows X server. And then in your PuTTY connection, because of course we're running PuTTY, right? You just have to check the box that says enable X11 forwarding. And so any GUI Linux application I run here will show back up in mode as well, which is pretty handy. So we're going to leave Wireshark running here, and actually I'm going to do one thing. I'm going to start a capture here. I'm going to filter by OF. We'll see why here in a second. So I'm just going to capture on the capture on the loopback interface. Because remember, even though this is showing on my Linux box, it's actually running on the VM that I have going here. Correct. Apply. All right. So we're filtering OF. OF stands for open flow, by the way. I only want to see open flow packets. All right. So we're ready. Actually, I don't want that guy. I want this guy. Ready to give this a try. So Mininet is actually just an application called MN that runs. And you run it all as root, so I'm doing sudo here. But if you do the help here, we can see what this looks like. It's a very, very simple application. You basically give it a network topology, and it creates the virtual network topology inside your Linux instance and allows you to interact. Okay? And it's utilizing the virtualization tools that are built into the Linux kernel. And so I'm going to have it create, I'm just going to run a default one here, and we'll see what it creates. Sudo mn. So, creating a network, adding a controller. We'll talk about all this in a second. Add a controller. It adds two hosts, H1 and H2. Adds a switch. Add links between the two. H1 is connected to S1. H2 is connected to S1. Configuring the host, starting the controller, starting the one switch, starting the CLI. There, Mininet. Okay. So we just started a virtual network. Let's see what this looks like. If I do hosts, HOSTS. Oh, sorry. Don't remember what these commands are. If you do question mark, it gives you help here. Links. Let's start with links. Okay, so it tells me H1 ETH0 is connected to S1 ETH1. H2 is connected to S1 ETH2. If I do the command dump, it gives me all of the information about my current network. So I have one host here. It automatically gives a 10.net IP to them. You can change that, of course, but that's the default. So H1 is 10.0.0.1. H2 is 10.0.0.2. The OVS switch, the open virtual switch. There's the connections there, and then finally the controller, right? So we all know networks, right? I can take a switch, I can take two hosts, I can run Cat6 cables between the two. I've got a network to do, right? Why do I have an extra thing in here? What's the controller do? We don't have that in our normal networks, right? Why do I need a controller?
That manages the SDN.
Right. It's the brains behind the software. It's the brains behind the SDN, right? So you've got to have some kind of controller in your network. This can be in software like we have here. This could be in hardware. In fact, Mininet supports talking to an external controller via IP to actually do the command and control. And that's where all the logic happens. That's what controls what happens with the packets, what the flow rates are, all that kind of stuff, right? So we have to have a controller here, okay? So now that I have both of these running, let's go back to my question mark. What else can I do? I can say nodes. That's what I meant when I typed host. I meant nodes. Available nodes are C0, H1, H2, S1. Okay, and I'm going to do ping all. Okay, so what it does here is it actually connected to both of my hosts, H1 and H2, and attempted to do a ping to all the other hosts. There's only two, so it didn't take very long, right? H1 was able to ping H2, H2 was able to ping H1. If I flip back to my Wireshark now, this is where we see some interesting stuff happening. So remember, this is the open flow protocol. I'm filtering on OF here. So Wireshark is telling me, hey, all these packets are the OF protocol. And what we're seeing then under info is an example of what's actually being passed in this protocol. Because this is all network encapsulation, right? Especially in this case because I'm running all on one host. If I do a ping between these two systems, I have to tell the controller on the network that this ping is happening. So that ping is essentially encapsulated inside an open flow packet, which is sent back to the controller. So we can see here that the protocol is open flow, and we can see what's actually happening here. There's an initial configuration, OF hello, OF features request, OF set config. This is the control plane network, or the CPN, is what it's called sometimes, right? This is the overhead of the network actually talking to all the different devices, right? There's no data happening here, but this is the administrative overhead happening on this network. If you have a large software-defined network happening, your control plane network might actually be a completely different, separate physical network, right? You have enough traffic happening here, and this one is big enough, you may have those be two entirely different networks. Obviously, that's not the case here on my one little laptop, but that's a possibility. So we can see features request, features reply, port status, setting configs here, and then here's echo request and echo reply. There's actually ping built into this. So directly in the open flow, we can test connectivity. We can see it's just checking what's up here. If I go back here, let's do one more thing here. If I do xterm, oops, sorry, I got to do it on node. So if I do xterm h1, this will pop up a terminal window on my VM h1. That's a little hard to read. Do I have config here? Here's my 10.0.0.1, right? So now I can ping 10.0.0.2 and get a reply back. So it's talking to the other host on my network. If I go back to my Wireshark, scroll down. There we go. We see packet in right there, right? OF packet in, OF echo request, echo reply. We see the actual traffic as open flow packets because I'm specifically filtering open flow. Right? But the point is you can just see this traffic actually happening right here. Okay.
What happens if you do an IP route?
That's really hard to see, but IP route says 10.0.0.0 because I have a /8 network on here, and then my source IP is 10.0.0.1. Right? I don't have a route out anywhere. It's just a private network. So that's okay. So again, taking advantage of the fact that Linux lets me do this very easily, I'm going to do an xterm on H2. So I have both. So here's H1 and here's H2 and here's H1. Right? So just to verify, do an IF config on this one, it's 10.0.0.1. Do an IF config on this one, 10.0.0.2. Two different systems, right? Well, not really. This is where you have to kind of understand how Linux is taking advantage of the virtualization built into the kernel. These two systems, although they share different, or they have different network configurations, they're sharing the same process space. So if I do a PSAX here, and pipe it through more, and do a PSAX, pipe it through more, they're exactly the same. Because this is actually running on the same box. This is different than if you had actual individual virtual machines running under each one of these, which you could still do, right? I mean, we could create a controller and then have independent virtual machines set up running the operating systems. But for our purposes here, in our test environment, that's unnecessary to do, and it's really unnecessary overhead. We don't need that. We just need the network virtualization, which is what this gives us. Okay? So let's go back to my Mininet here. So we did, if I did the dump, remember, if I do dump, it'll tell me exactly how the network is set up. I did the ping all. I did links. I can type links. There's the links, right? Okay. I'm going to exit out of this, and that shuts the whole network down, right? And notice that it killed my xterms as well. And there's no more open flow traffic happening here. Okay. So, what kind of things can you do with this? Well, because you can emulate pretty much any network environment, you can create your network model in here. You can test connectivity. You can test firewall rules and packet flow rules. You can do your own kinds of routing or packet filtering because you control the controller, right? The network controller. You can also set up these links and define them to match certain speeds for your testing purposes. There's tons of examples at the Mininet example directory here we'll look at in a second where that happens. So I'm going to emulate a 10 meg connection over here and a 1 gig connection over here, and then I'm going to do a bunch of network tests through this to see how this all actually works. You can do that right here on one system without having to have any hardware or anything in place before you actually roll this out to production. That's one of the really big advantages of Mininet, is the ability to kind of play around and stuff like that. So the other nice thing about it is it's scriptable. And if I go into the Mininet directory here on my example distro and look at examples, there's a bunch of Python scripts here. Python is the programming language of choice for Mininet configs. And there's examples of what you need to do to actually deploy, programmatically deploy a network in Python. So here's a very simple script that will basically create the default network that Mininet does. So it's 2 hosts, 1 switch, 1 controller. This is all done in Python. So it imports, if you've done Python before, this will look pretty normal to you. It imports all of this Python stuff first, so it has access to all this stuff, right? And then you define this function called myNetwork. You set an IP base. You add a controller. You can see these functions, net.add controller, net.add switch, net.add host. We're defining everything right here. The class here, we can actually define what kind of switch we want. The 2 main types are the OBS switch and the legacy switch, which actually doesn't have a lot of intelligence in it, but if you're modeling an older network, that will work just fine. You start the controller, you start the switches, right, and then you run it. So the way to actually implement this is just a Python script, so you run it. And run it as root, of course. There you go. Adding controller, switches, hosts, links, starting network. If I do a dump here, it should look just like we did before. I should be able to type ping all here. H1 can ping H2, H2 can ping H1. Easy peasy. Okay. Let's get out of there. Let's change that a little bit. So here's one I created earlier. I just called it topo for topology. I actually modified one that came with the installation that created a 1,024 host network. It's not doubling, it's 4 gig of RAM. I'm a little wary of trying to create a 1,024 host network, so I didn't try it, but I did modify this out here. So this is an example of another way to set this, where you don't have to define every host individually in your API calls. You can do it using this treenet function, which basically says how wide and how deep do you want your tree of devices. So here I'm saying depth of 2, so I'm going to have 2 levels of switches. Fan out being 4, it's going to be 4 wide, right? And then that type of switch, and then it calls it. So let's run this and see what kind of network it creates. There we go. A little bigger than we had before. We have 16 hosts, H1 to H16. 5 switches. There's all the different switch links. Configure all the hosts, starting the controller, starting the 5 switches. Okay, if we do a dump here, we can see all the configs. There's the IPs, right? 1, 2, 3, 4, 5, all the way to 16. There's all the connections. And finally, we can verify connectivity by doing the ping all command. There. So it goes into each host and pings all the other hosts to verify connectivity. And they're all going to be up. So it works fine. There you go. Doing pretty good received. So if you've got a little bit of Python programming ability, you can not only script these to be created on the fly, but you can actually modify these on the fly too. If we look at, oops, our question mark here, that link command can add additional links. Switch command can add additional switches, right? You can modify your actually running system here. Okay, I'm going to exit out of here. One other thing I wanted to show you was in the Mininet examples directory, there is a Python script called Miniedits. So if I do sudo Miniedits, this actually spawns a TickleTK application. We've all programming in TCL and TK, right? And it is actually a very, very simple GUI network layout model. If you've used any of the old Cisco tools for creating this in the past, this should look a little bit familiar to you. It's pretty rudimentary, but it gives you an idea of kind of what is possible. So I'm going to create a network topology here. I'm going to say, give me a switch right there. Give me another one here and another one here. Now give me hosts. 1, 2, 3, 4. Give me a controller right there. Now let's make some links. S2's got to talk here. S3's got to talk here. Connect these here and these here. These here and these here. And the controller has to have a link back to every switch. Man, not the prettiest network model in the world. But
Can an H be hooked up to more than one S? Or would that be dumb?
Yeah, absolutely. I mean, for redundancy's sake, right? So you're talking about like layer 2 redundancy at the switch level, and handling essentially, I mean, what we kind of can call routing tables at layer 3, right? So this would be layer 2.
So one of them is the main one, and one of them would be a backup.
Right. If you're going to do that, you can't just kind of blindly plug it in, because you'll create a switch loop, and your traffic will sit there and run and run and run and run. You'll wonder why your packets have gone to hell, and the lights in your switches just do this all the time, all the time. So you have to actually configure the software to support that. So yeah, most of the layer 2 redundancy software that's built into the switch operating systems will identify one link as kind of a master and one as a backup. So it'll only come up if there's some kind of a cut at the layer 2 level. Do you guys work for companies that implement layer 2 redundancy in your networks? Do we really? I mean, I wasn't trying to be a jerk like that question. Do we do it at the office? I don't even know.
No, but I used to work.
Well, you used to work. Okay. So describe how you set that up from a layer 2 redundancy level.
It's a pain in the butt.
Okay. Fair enough. What did you have to do? So you'd have basically every box, because what you're asking was basically, could I make this guy dual homed, one to one switch and one to the other, right? Would every box be dual homed then?
Well,
or would the switches
every box you wanted to be dual home. Yeah.
Or would you just do the redundancy at the switch level? Because that's another option, right? You could have these. You could have a line here. Have these switches talk to each other. So if this guy goes down, it's okay because, well, crap, it would still sort of strand these,
You'd
right?
have to be the host.
It still have to be the host.
Typically,
Okay.
what I'm seeing.
Go ahead. I asked you a question and I started talking.
At both places, right? S3 and S2 would be connected together, and then you'd have whatever host you want to have dual home to that switch. You'd have, yeah.
So they have to do that. Okay.
Well,
So
we
a lot
do
of extra wiring.
have wide cables that we have to switch.
Okay. So yeah, that'll have to be dual home basically. Okay. Then you have to configure on the switch to handle that. Okay. So we're not doing that here. But I created this simple little network model.
Does this allow you to specify the link speeds and stuff in here?
It does not. You have to do that after the fact.
Okay, so after you write this out, I'm
Right. No, you're fine. Yeah, this is very, very simple. This is almost sort of like a proof of concept of what you can do. Because all it's doing then is creating the config, creating the Python that we're going to save. So I'm going to say export level 2 script here. I'm going to say new.py. In my examples directory, if I go back here now,
Was that just showing you what was included?
what was in
When
what?
you save that, was it showing you what was being included in the script? No, it's just all the time.
No, it's just all the
Oh,
different
okay.
Python files in that directory.
Sorry.
Fine. So I'm going to, let's see, I'm going to go back to my VM here because otherwise I'll kill my, well, that's not true. I can do another putty session. Actually, sorry, I have to do that here. New session. Minutes. Sorry, I didn't have this set. New system colors. Apply. I'm just going to save my font changes before appearance. Fonts. So this guy here, if I go to Mininet examples, it's called new. I have to make it executable. So chmod +x new.py. Okay. Now I got to kill the other one before I run this. So I'm going to go back here, and I'm going to actually I can just close this. There, it died. Okay. So I don't have Mininet running now. So here I can now say, I named it new, right? So I can say sudo new.py. And there you can see it start up. Adding controller switches, host links, H1, 2, 3, and 4 in that order. Starting controller, starting switches. If I do a dump, we'll see what my network looks like. 10, 0, 0, 1, 2, 3, and 4. There's the connections. One controller talking to all the switches. If I do a ping all, there, everybody can ping each other. Okay. It's a very simple way to model your network diagram in this software. And then it creates this Python script that you can run that models the network. Okay. So very easy to do. A few other things to look at. You can configure your links individually, change speeds, change type. You can configure the logic behind the actual packet movement at the controller level. You can write your own controller for how the packets move between your network. You can talk to an external controller. So if you have a relatively recent Cisco switch, I don't have an exact iOS version for you. It supports the OpenFlow protocol, and you can have it actually act as a controller for your network. So you can model this network, but test it against whatever kind of switch you're going to be running this against before you deploy it in your production environment. Because this is Linux, of course, you can run it on a VM, you can run it on an EC2 instance, you can run it on pretty much anything that runs Linux, right? And the requirements are relatively low. The controller especially doesn't really take a whole lot of memory and CPU to actually do this. And then finally, it's all open source and Python based, so you can change it. You can kind of do what you want. There's a huge community around doing it. And yeah, that's pretty much it. So, any questions? Yes, sir. Right. So when I add a link here, I can define exact. And I didn't do this in the software, but like if I exit out of here and I look at new.py, there. It's one of the options to the net or the net add host here. Or no, I'm sorry, it's the add link. There's an option I could pass to add link that would say this is a 1 gig link, this is a 10 meg link, this is a 20 gig link, something like that, right? And it will respond accordingly. Your pings will, honor that setting. Essentially, your trace routes will honor that setting.
And you can also simulate like distance, like induce simulated latency.
You can manually induce latency in the link itself, right? I mean, you can't say this link is 20 miles long because it wouldn't know what kind of latency to put in there, right? But you can induce, yes, X number of milliseconds of latency, and it would correctly emulate that in all of your tests. Yeah, that's a good example. That's kind of what it's used for, right? One thing the documentation does make a note of is if you're trying to test links that are 10 gig or greater, there's a pretty good chance that your system is not going to be able to keep up with that. So you're probably not going to have accurate timings if you're looking at 10 gig or higher. So we all have the luxury of 10 gig links. We're probably not using Mininet to do this.
What about MTU? You set the MTU?
I don't. The question is, can you set the maximum transmission unit of a? Well, that wouldn't be of a. I guess that'd be on the host side,
Yeah, the
right?
interface side, right?
Right. I don't know. I didn't come across that in the documentation as something you'd be able to set. But that gets set. I mean, that doesn't. I'm trying to think where you just set that. You set that like on the host interface itself, right?
One side or the other, the switch or both. But you can simulate.
Do you usually set that on a switch? I always thought
Yes.
you just set it on the host
You
name.
can set it on a switch.
You can
Typically,
set it on a
like
switch.
if you're Cisco-centric, it's usually 1500 or jumbo frames.
Right, or
But
jump.
you
Yeah.
can do weird things too. That's why I bring it up. Because
You do
can
1496 or whatever it used to be, right? That would break a bunch of crap. Yeah.
could simulate weird MTUs on either side.
Right, if you're having to deal with archaic networks, yeah. I would think you'd be able to. I'd have to look in to see how to do that. I don't know. It's Mr. Gruffy.
So will it do fragmentation also? You can create a portable plane on the MTUs and allowing you actually.
Yeah, right. If you could set the MTU, you'd think you'd be able to do that, right? All the stuff that I read about and the way I've used it is really just focusing on identifying the speed of the link and having it represent that accurately, as opposed to, you know, dash option shitty WAN link that goes down all the time, right?
I'm betting it doesn't.
Probably be more useful, which we all have to deal with, right?
You run on the loopback interface on the local machine, so if you look at the MTU on your local loopback.
Oh, there you go. It's going to have to honor. Well, it's except it's inside the virtual environment, though, right? So it wouldn't necessarily have.
But my point is, it's rather large on the local host.
Oh, by default, the loopback on the MTU or the MTU and the loopback is pretty high. Okay,
Something like that.
that's fair.
What about routing protocols?
Well, this is all layer 2 stuff that we're
So you
dealing
can't
with
really
here,
induce.
right?
Usually you can play with how things are routed.
There was a router.py.
That was an option. That was an option there. Yeah. You know, to tell you the truth, I've only ever done this on layer 2 networks, so we'll have to try that. Yeah. I don't know the answer.
So that was kind of my question as well. Is this strictly a proof of concept kind of thing, like a Linux-based, or not, because GNS3 is also available on Linux, but is this like a GNS3 test environment, or can you actually use this to push configs out to actual hardware? So say I've got a Cisco switch and a router, so I can use that.
The answer is both. Yes, this can be your front end to actually talking to a specific controller or a specific switch, as long as it supports OpenFlow.
Okay, and do I lose some robustness from perhaps a proprietary, like configuring Cisco with Cisco protocols?
Sure. If they have any sort of weird hooks in there that you want to use in Cisco specific, yeah. I mean, it's no different than if you're using, you know, EIGRP versus OSPF on the routing protocol side, right?
It would have to be able to set the MTU. If you can configure the interface, that's one of the subtle.
Yeah.
So it's probably there.
Documentation. Mininet.org is the main website. There's also there's a good intro to Mininet over on the GitHub coding page that talks more about the Python API and what you can and can't do. So here's like a whole section on OpenFlow and custom routing. And they talk a lot about the different controllers and the different kind of controller software and logic you can have in here. I found this one as well. This was a presentation that was given by some instructors back in 2014 called Teaching Computer Networking with Mininet that has a lot of really good examples in it. And we'll put all these links up on the website. And this is a little overview. This is a WordPress site that has an update to Mini Edit. This guy has kind of taken the default Mini Edit and made it a little bit more robust, so it has more options in the GUI. If you're using this as your main configuration option for the networks that you're laying out, you do that rather than doing it through Python. So there's some good stuff in there.
The legacy switch.
Yeah, the legacy switch. So like this says, legacy router tool creates a basic router to operate independently without a controller. It's basically just a host with IP forwarding enabled. Legacy router cannot be configured from the Mini Edit GUI. So you can use router config, but you'd have to do it actually from the command line instead of from the GUI. All right. What else?
It's pretty cool.
Anything else? Yeah, it's pretty cool. It gives you, the really neat thing about it is the ability to test your network config before you actually roll it out in production, right? And then, of course, enabling you to have a relatively easy framework for software-defined networking. It's not something we've done before. Even on smaller networks, you know, it can be useful from a control standpoint. And your controller can be, I mean, Mininet can actually act as your legitimate controller, you know, for a network. You can put this on a Linux instance and run it as your controller. And define, you know, do the packet monitoring here, define how the packets work, and change how they flow through the network.
Cool.
All right. Cool. All right. That's all I got. Thanks, everybody.
Thank you. been any things going on in the Linux realm lately?
You should tell us.
Anybody using?
I know.
Anybody using
had a
Ubuntu's
chance
Bash
to
on the
reading.
Windows server yet?
I started yesterday.
Did you really? What do you think of it, John?
I'm new to Linux, so
Yeah.
I did basic stuff and I can get around, and it looks like a normal.
Looks like normal Bash, right?
Yes.
That's kind of an interesting idea.
Is there a downside of running it on Windows versus
We were talking about this. I mean, there have been implementations of the basic Linux command line utilities on Windows for years. I mean, Cygwin was kind of the big one. I think what we kind of decided in some of our internal discussions at work about this was that what this gives you is access to some of the kind of lower level APIs that Microsoft publishes that maybe some of these third-party tools don't have access to, right? So you've got, if you liken this to the PowerShell, which is sort of the beefed up version of the command line that's shipped ever since, what, Windows? Thank you, okay. Where it actually had command line object access to a lot of the main objects inside the server. That's what you can get with this kind of official version of Bash as well. So, like communicating directly with like some of the container objects and things like that that Windows references its hardware with, like disks, video cards, and things like that. You can talk to it sort of the appropriate way rather than trying to do it the native Linux way, which didn't always work. And the example I can think of is referencing a drive in Cygwin was always weird. You had to do //Cygwin/C/whatever, and you don't have to do this in the kind of the official version of Bash. So, but if you're just learning Linux, it's a great way to learn the command line tools. It's already there.
I did a pretty heavy amount of reading into it
Yeah.
to see what was up with it. And from what I gathered, it's pretty much explicitly intended for development. It's not really meant to be a general use thing. It completely lacks the ability to do any Windows system calls. So what you're talking about, it does pretty well. The fact that people finally actually navigate a file system.
So it's not going to interact with the GUI in any way.
Not at least not yet.
Also, PowerShell even has it
I was
there.
reading on one of the discussion groups on that. Some of the Windows developers were talking about that's something they'd like to get going, but as of right now, it's very, very alpha/beta stage. And they don't have anything lined up exactly yet to get any sort of
So I wonder what the
abstraction of the concept in Bash.
right. I wonder what the connection, if any, there is between the PowerShell teams then and the Bash teams.
And they even
Right.
said if you're looking for more advanced interaction with Windows,
PowerShell.
there's always PowerShell right
Right.
here.
That's
It's
been-
a sophisticated tool.
That's 10 plus years, man. It's been around for a long
To
time.
PowerShell's defense, it's pretty dope.
I
PowerShell can
totally agree, man. They did a
stuff.
good job with it, right? It's the command line interface that we wanted with Windows from day one.
Yeah, it has a lot of the Linux nicknames. So if you're moving
Yeah.
from a Linux environment, your basic Linux command that you're used to, you can still run them in PowerShell.
Well, I mean, that's kind of the first thing I thought of when I first saw this announcement. I thought it felt like a solution looking for a problem. What gap does this fill that PowerShell or Cygwin don't?
I assume that they plan to deprecate PowerShell at some point with this because they've got a long list of things, of features that they're planning to implement with the new Bash functionality that obviously are going to take time.
On the blog when they announced it, there was a few developers that hopped in and were very adamant that they were not deprecating PowerShell, and that you really should learn PowerShell.
Yeah, they'll say that till the day it's
They
deprecated.
basically kept reiterating that this is basically just a way to pull more developers over Windows, so they don't just outright quit Windows. So they
Well, if it's in a cloud environment where they're managing a lot of machines, they don't want to have to remember 2 different ways of doing things. So if you're pulling up Windows 2012 where it's just the core and you have no GUI at all, it could be advantageous.
Does it come with an SSH server?
I don't recall.
Is that easy to do on Windows? I mean,
think Windows 2012 comes with
I did that on Windows 100 years ago, but it was a giant P to do it.
Windows 2012 comes with
Is that a thing you can enable now?
I
think it comes with
I'm trying to remember back to class.
a role or a feature that you
As long as you open the firewall rules to do it.
Well, sure. But I didn't know if the code was actually Microsoft code or if it was just an implementation. BSD.
Embrace, extend, and extinguish.
Well, they've had this NFS since 2000. I know
It's been a long time. That part of that Unix kit.
Are they still supporting NFS? Really?
Yeah, only if you're by Pro. No, it's actually even there without Pro.
I can use that.
Well, they had to because Linux boys won't live without their NFS.
Yes. What's going on with OpenSSL, John?
Big update. So there's a high severity that you could get an out of bounds memory write leading to corruption, and we know how that's going. So they actually pre-announced this last week, so it finally dropped a few hours ago. So everybody, update. Come on, guys. Bonsai.
How have the distros been about putting out new package versions of this? You know,
They're usually right on top of it. If they've got CVEs assigned to them, they're usually. Everybody's coordinating all these releases anymore.
Red Hat will be tomorrow. Oracle will be a day after that.
Slack will be at Christmas.
Yeah.
Oh!
Christmas.
No love.
Christmas
No
2017.
There is no exploits in the wild at this time.
Oh, that's good.
Okay.
So that was 3 hours ago on that.
Fedora got pushed back a week.
That's right. They did a go no go for 24.
4.
Yeah. So that's slightly delayed. Cannot remember what's new.
I was going to say, if I've got 23, why do I upgrade to 24? What's new and fruity? You know,
I don't remember.
GCC 6.
Yes.
Really?
Oh.
That's a big deal.
C++ 14 is the standard now.
What was that?
Playing with
C++ 14.
Okay.
We've been playing with Ubuntu 16.04.
That's a big deal. What's that? 8? What's that?
New Ubuntu release 16.04.
Oh, the new Ubuntu release.
Yeah.
Ooh.
Everybody played with it.
I didn't know it was out.
You missed.
There you go.
Myth TV.
0.28 came out last month.
Myth TV talk, John.
A while. Still running the same one I've got.
If you loan me that PVR card, I'll do a talk on how to digitize VHS tapes under Linux.
Oh, that's true. I gotta get that. It's in my office. I'm gonna grab that too.
That's cool. That's
Yeah.
still around.
I just actually installed a TV antenna in my attic for better reception.
You still run a Mythbox now? Does anybody work with the DVR options under XBMC now? With the newer, what's Kodi?
Kodi?
Yeah, it's not. Yeah.
But it actually has
Is it
DVR options. I have not. Since I went with
It's probably
Plex.
the HD home run.
I went with Plex. I don't give.
Plex is just too good.
It really is, right?
Get that on your Synology.
I do miss the XBMC UI, but
The Kodi, like, well, XBMC, yeah, it was slick.
it's pretty slick. Other than that, Plex is pretty.
Sweet. So Aaron will give me the name of, you know, Jay just did a Git in September.
Well, you're more than welcome to do one.
I'm trying to think, you know, would anybody want another Git presentation? That's this quickly. Because he did 101, right?
Yeah.
So maybe more advanced kind of stuff.
That's pretty good.
Okay.
Yeah, it'd be interesting.
There's better be more than just.
I'm going to time this so when Eric walks in the room. I'll say, thanks. So, yeah, so for June, we'll probably get Dave, and he looks like he's locked out. Can you go let him in, Craig?
But Eric is all hides.
We're back in the other room. All right, so that's pretty much it for May. Thanks, everybody, for coming. How's it going, Eric?
Aaron, you got any fun, like a little HDMI or single board Linux computers you're working with lately?
I'm waiting for my pocket chip to show up this month.
The Pocket Chip?
Just takes the chip in, puts a full screen keyboard.
Really?
Yeah.
That's cool.
Anybody have a Raspberry Pi 3 yet? Yeah.
Ooh, of course.
How is it? How do you like it?
I have not opened the box.
Oh, I was gonna say, my question was going to be, is it noticeably better than whatever you're doing?
Sorry.
Raspberry Pi 2? Well, that's pretty nice.
Yeah.
We have one at work to run Nintendo emulators to play Super Mario Brothers.
Yeah,
That Slater's over.
yes, there.
They should get some around to us next month. So.
I'm still fighting with OpenHab.
Yeah.
So that's supposed to be for July.
Oh,
Yes.
what's there's an it's not Nokia. Who's the not OpenHab, but the home automation hub? Nokia? No.
Smart things?
Yeah.
That Samsung bought?
Samsung. They got hacked.
Really?
Yes, there's an exploit to turn things on and off.
That's never good.
So there's a script called Home Rave
I don't.
from the lights? Maybe? Okay. Right. Thanks for watching at home, everybody.
All right.